let's solve for the remaining sides and angles. Well, we actually have all the sides, so let's just find all the angles. So here we definitely cannot use the law of sines, and we don't have any other tools but the law of cosines. Okay, so we're going to use the law of cosines. We're going to have to rearrange it a little bit to find one of these angles, and then from there we can see what we can do. Now, my general first strategy, okay, my first step, this is what I always do, and I find that it works best. Find the largest angle first. Okay, and you can tell which one's the largest angle because it's across from the largest side. Okay, so C is 13, B is 10, A is 7, so the largest angle will be across from the 13. Okay, so that's gamma. All right, so we'll do that, and then we'll talk about the next strategy later. Okay, so first step, let's use the formula that has gamma in it. Okay, so that's the one that says C squared equals A squared plus B squared minus 2AB cosine of gamma. Okay, now we're going to rearrange this a little bit, and I'll show that. I'm going to subtract A squared and B squared from both sides. So C squared minus A squared minus B squared is equal to negative 2AB cosine of gamma. Then I have to divide both sides by negative 2AB. So I have C squared minus A squared minus B squared over negative 2AB is equal to cosine of gamma. And then I use the inverse cosine to get gamma by itself. So gamma, I'm also flipping this around, gamma is equal to inverse cosine, or arc cosine, of C squared minus A squared minus B squared over negative 2AB. Okay, so that's just a rearrangement of the actual law of cosines. Okay? All right, so let's actually go and plug all that in. So let's see, I'll just bring that back up here. Okay, so inverse cosine, C squared minus A squared minus B squared over negative 2AB. And so in my calculator, I will type this in. Inverse cosine, 13 squared minus 7 squared minus 10 squared over negative 2 times 7 times 10. Close my parentheses, and I find 98.2 degrees. So gamma is the largest angle, and it's 98.2 degrees. Okay, great. Now we can go on and try to find another angle. That's what's going to bring up my second general step. Okay, so everything's fine here, but what I'm going to say is second. Let me say second. Find the smallest angle. Okay, again, this is just the strategy that I found works the best, okay? Don't necessarily have to do it in this order. Okay, so let's find the second one. So to find it, I'm going to use the law of sines. So sine of, let's find alpha, because alpha is the smallest. And I know it's the smallest, again, because it's across from the smallest side. Sine of alpha over 7 equals sine of gamma over 13. So once I rearrange this, I get alpha equals the inverse sine of 7 times sine of 98.2 degrees over 13. So that's what I'm going to type in my calculator. And I get 32.2 degrees. Again, that's the first one. Let's see. We have a potential second. So 180 degrees minus 32.2 degrees. And that's going to be way too big, but that's 147.8. Okay, obviously that cannot be an alternate triangle because 147.8 degrees added to this 98.2 degrees is well over 180. Okay, so we would say that that is not a possible triangle. We only have one. So alpha is 32.2 degrees. Okay, now let's find beta. Okay, so beta will be 180 degrees minus gamma, 98.2 degrees, minus alpha, 32.2 degrees. 180 minus 98.2 minus 32.2 is 49.6. Okay, so beta is 49.6 degrees. There we go. We found all the angles. Now, it's important to note that if you have all angles and no sides, you cannot solve that triangle, okay? You have to have at least one side, but if you're given all sides, you just use the law of cosines to get started. If you're given all angles, there's no solution. There's many, many triangles, an infinite number of triangles that could fit that description, okay? So there's not one solution. Okay, so there we go.